Well, hello everybody and welcome back to a new episode of the TypeScript Tea Time. I'm your host Mirko and hope you're having an awesome day today. We're going to continue where we left off yesterday, which is how do we actually connect AWS GroundTruth, which we use to essentially provide the solutions that our AI can then train on, our machine learning algorithms can then train on, and also the validation, for validation. Not just training. We used GroundTruth to do that yesterday, an AWS service. And today, what we want to do is actually create a training model from that. That's where we're going to go off from. Where we essentially stopped was this nice little notebook, or Jupyter notebook, which provided us with a lot. So what I also did, I essentially recreated my account, and I did finish the labeling job. So that was fun. And as you can see here in the labeling job, we have nothing in there anymore because it is actually finished. Other than that, I opened this again. So these are the Jupyter example SageMaker examples. If you go to notebooks, so inside of AWS SageMaker, you can just look for SageMaker right there, which is the machine learning service from AWS. Click on there, you get somewhere here, or probably more like here, I suppose. And from there you can continue. How to get to the notebooks is basically by clicking here on the left side onto notebook instances, create a new one, and then open it. And what you will see is something like this here. Actually, we'll probably start here, then you can go to the examples. And down, we see GroundTruth labeling jobs. And that's where I took this object detection tutorial. So, other than that, we should have, if I go into my S3 bucket, S3. So how is everybody doing, by the way? How are you? First of all, let's take a cup of tea. So inside of here, I have this tea time test. Everything is called slightly different because I completely recreated an account, essentially, because I don't want to pay as much for just this testing, and that's what exactly the AWS free tier should be there for. Then I put everything in GroundTruth, and inside of here we see the dataset, and I think we also see this output. Foods and cosmetics was the name for the job that I gave. Other than that, we have all the JPEGs that we have here, which were used for the actual labeling job with GroundTruth. And in here we now have the results. Probably we have something like, so if we go to the job name manifest output, there is. We have an output manifest right there, which we can open. Folder. It is essentially just a JSON array. But it does not actually do the array thingy. Instead, it's just one line is one JSON. Do you not realize that it is actually JSON? Language mode, JSON, kind of. Yeah, that looks better. We cannot, unfortunately, format this, I think, because it's not really an array. More like JSON per line. So, but what we see is we essentially have inside of here, what do we actually label? In this case, it's the image that has this paths inside of the S3 buckets. It is part of the food and cosmetics job. We have just the regular image size. We have the annotations, which are the results that we, the bounding boxes that we provided for the images. And we see like top, probably the class ID is just the ID of the label. We only had one label, so because we only have one object that we want to identify, which is, if we look at any of these pictures, we want to have the, these are my cookies. Hey Hector, good to see you. Today we're doing some AWS stuff. Here's on you. How have you been doing? Everything good in the C# world? So this says ingredients, and I wanted to label basically this part of the ingredients. If we have something like this here, it says ingredients more obviously, and I essentially have exactly this violet box as a bounding box, but provided manually, and these are the coordinates for this here. Top, it's like 2412 pixels from the top, maybe like here, and left it's like 300, so about 1/4 in. Maybe this is actually the right picture. Sodium, hey there, back in. Good to see you. How are you guys doing? So I did all of this labeling, and we now have these bounding boxes inside of there. And we see here even the type is GroundTruth object detection, and it is human annotated. And all of these are actually labeled now. So all of the 52 pictures have been annotated. So what we want to do now is essentially, if I look at this, at this Jupyter thingy, notebook, what we want to do is we take this output, this here, and I think it's called augmented. No, maybe not. Never mind. They call something augmented manifest. I'm not sure whether we have the right one, but I hope we do. At the very least, it's called output.manifest. So that's exactly what we have. In here, they split it into 2 manifests, and we can just do that ourselves. I think we just take the first like 40 lines, 41, let's say. Create a new one inside of here, which we call train.manifest, and put this one inside of there. And then they create a new file, another file, which is called the validation manifest. Validation.manifest. And there they put the other images. Where is it? There it is. That's all this here is this is doing here. And since everything is already, there is no order in my pictures, so I don't need to shuffle anything. It is randomly ordered by default. So, all right. Then they upload those into it. So they use the AWS CLI to upload these thingies, which we can do as well, I think. So let's see. Does it say not? What is this? That's probably a shell command inside of the Jupyter manifest. So let's see. Where do we have the usage? Okay, somewhere here. So we have create train.manifest and validation.manifest and upload to S3. So in our case, it should be something like this. I have to use minus minus profile. My profile name is here. And we actually have to set the region. I think we have to set the region as well. US East one, right? That's the is that a default one? Kind of forgot. S3 is global, so you don't really see it. North Virginia is US East one. Yep. So from there, we do have train.manifest, so that one is alright. We have to set bucket. Bucket is equal to it is equal to it's one bucket, and exp name is equal to, so this is just shell now, or shell commands. I think I did put it inside of here, so it's foods and cosmetics. Do I put this into manifest? I hope not. However, not enough. I mistakenly called this GroundTruth input, but that's actually, I think we need this one. Now the question is, can my shell properly handle the slash exp name? It can. Okay, perfect. So that should upload the thing. Invalid bucket name bucket. Because we do not have a dollar. Should say dollar. Do it again. Uploaded to S3 T time test blah blah blah. GroundTruth input foods and cosmetics train manifest. So we should see this right there. Very good. That works. And similarly, what was the other one they were doing? The validation manifest. Right. Copy this one and call this validation.manifest. Since I'm using the same shell, I do not have to recreate these environment variables. Okay. So that should, can I update this? There should be an update button right there somewhere. That worked. Very nice. Next. What do we do now? Now we create the actual, so here we define S3 file paths for input and output data, the training image containing the object detection algorithm, and instantiate a SageMaker session. So this is going to be interesting because we basically have to rewrite this into CLI commands, I think. AWS CLI SageMaker. It should be a thing, right? Yeah, it is a thing. Very nice. So, because I do not have anything Python-like set up, I actually have to do this manually, kind of. We could also try to set up Python. Yeah, I'm not sure whether that's the better idea. So, prefix role. Oh, this might be a problem. Get execution role. Where do they get this one from? From SageMaker. Import get execution role. Hmm. Anybody knows what this one does? So other than that, that's fairly simple to read. So they create a new session. They also link a new S3 bucket, or they just take the S3 library part, I think. They define SageMaker.Amazon estimator get image URI. Photo 3 session, region name, object detection, repo version latest. Not sure what this one does. Amazon estimator. So do they actually do anything inside of here? I don't think they do, right? They only define stuff, but they don't actually execute anything. Or does it actually? It does execute, right? This one might actually do something. Is this actually doing the thing? Attribute names. Oh, down here. I think that's it. So we create a job with these parameters probably. We have to actually recreate this all using, and here it actually creates the job. Create training job, there it is. With all these parameters. This is I think the Python spread operator, right? So if you write in JavaScript ... for an object or an array, it's pretty much the same here. If I remember correctly. Then they just look at the status and wait for it to finish. So, being said, might actually have to set this. So, setting up a Python environment is not that easy. Still. Do I have Poetry still installed? Poetry. Let's help. Poetry, new. // GroundTruth to SageMaker. That seems to have worked. Alright, there it is. And now we can use Poetry to install? So Poetry is basically your NPM or one of the NPMs for Python, however. So inside of here we can install something. Poetry install Boto 3. It has get execute from SageMaker. Also install Poetry and time. Does SageMaker originally appear? Import SageMaker. Boto 3, Boto core, and SageMaker. Boto 3. Where do we use Boto core? Nowhere. Is it just too many arguments? Poetry install Boto 3. It's add. poetry add photo3. That's better. Oh no! There's no version of photo3 match anything of this, and photo3 requires Python greater than 3.7. Photo3 is forbidden. What is my Python version? Oh, damn it. Python 3. 3. Okay, so this one is not working. Upgrading Python is also probably not going to help me. Like, not going to be that easy. As easy as I would hope it to be. Okay, so that's annoying. Very annoying, in fact. Is it? Right. Python. Ubuntu. Like, we say Python, sudo app list Python 3. Like, oh, it only has 3.6. My Ubuntu. Yeah. Okay. Right, so that's not an option. In other words, we have to do this instead manually, I think. Train an object model. This is going to be fun, I think. The train data path. So, let's see. We're basically going to recreate this now using the AWS CLI, I think. That's what we're going to do. So, augmented manifest file name train is train.manifest. Okay, so that's not terrible because we can just use whatever we have here to continue. So, create the machine learning they call it training job. Create the SageMaker training job. So for this to work, we use shell and we define this fun stuff. This is the variable which we call validation manifest, equal to this one. And you need to write validation correctly, otherwise it won't work. Then, similarly, we can call the train manifest. So, train.manifest. Next. S3 train data path, that's exactly what we have here. Validation by data path, there we go. Then augmented manifest S3E is S3 train data path dot split bucket name, which means it splits right there, right? Then takes the right part of it because it's taking the one right there. And then it's doing 1 colon. So it's taking everything. To have essentially think this. read, decode it into UTF-8. Why did we upload it if we download it then? S3 object. Yeah, they are downloading the object here in UTF-8. Then they split the lines again. Why did they upload them in the first place? Number of training samples. Okay. How do we use this here? Down there. Okay, I just know the number, so that's fine. Attribute names. List JSON.load augmented manifest lines at 0.keys. In our case, attribute names is, I think, just attribute names is equal to, go into rain.manifest. They look at JSON.load line 0. They look at one of these dot keys. If meta, and then the actual attribute names are attribute for attribute and attribute names. Iterate over everything. If meta is not an attribute, meaning everything that is not in meta, right? So format put the meta data from the labeling job. The class map. There is no meta object. Good. Oh no, there is meta. Okay, so they remove all of this fun stuff. They just leave this, I think. Right. If attribute name equals source ref okay, so it should look like this. There we can do. Here comes the fun part. Is this now? In this case, it's an array. How do we do that with a CL? Create training job is, I think, what we need to look at. They have like an example that would be amazing. Example, maybe. Nope. Nope. Oh boy. The output. Why not just include an example? Oh, this looks promising-ish. Type. Not fun. What's a better way to do this? we can maybe try to deploy this bad boy here, and then use a copy, and then we can just change the code inside of there, and I hope we can execute I guess that one. Yes, we said that one. I go down there. So train something. And there we go. Alright. So once again, go in here. And now we can set and just write attribute names is equal to this, and this is not it. Instead, it has to be foods and cosmetics. There we go. So we remove all of this because we just defined it, right? So create a new job. Perfect. See, I think we have to add some more name. This and X name is what he said. Right. So how do I execute this part here? Anybody knows how to use these kind of Jupyter Notepad thingies? Just want to execute this one. Nothing else. Fun. Code better execute error sending HTTP request and maximum retry. Make sure Spark has enough available read, so restart the kernel. Seriously? Hard. Are we good? Nope. Maybe Spark is the wrong one. Change kernel. I don't know, PyTorch, or that one sounds. Amazon. Yeah, let's take that one. Maybe that works. Train an object. There. And now, you, my friend. Where do we actually import Boto? Invalid syntax. Oh, because that's not a... It needs to be a string. In Python, of course. This one too. Try that again. But this time it's working at least. Very good. Something has happened, I think. Very nice. So. Oops. SageMaker is not defined anymore. Oh. Didn't it work like 3 seconds ago? Why is SageMaker not defined? Thing. Can run these first two, and then ignore all the rest. Maybe that's the issue. Or we have to install SageMaker somehow. Man, this is fun. Not. It is not imported, right? Where's my bucket name? It is the prefix. Down here. Let's put this one there. Bucket name is one. And exp name. That's a different one from what we have down below, right? Where do they use experiment name? Ah, right here. So maybe we are going to take this one and we upload these guys once more instead. Well, these two and upload these bad boys once again. Oh boy. No. Yeah, upload. Alright, so now the experiment name is correct. Set this one to false. False. And now we can run this one. That worked. Yes. And we can run this bad boy. Good. And the rest we skip. Go down here. And inside of this one now. S3 prefix. Oh no, that one has changed, right? S3 is the experience name. The experiment name. So, like these two. We have them defined up at the very, very top, and we should now have them in our context. So, run there, bad boy. Method get image URI has been renamed in SageMaker Gradle 2. So the The Jupyter seems to be outdated. The notebook. Defaulting to the only supported framework algorithm version 1, ignoring framework algorithm status. Get image here. Did it do the thing? So the print training image. Did it do the thing? Yeah, it did. Very good. So that seems to have worked. Then next one, we can go in here. We can just run this. So this is just getting the paths from the training manifest. There we go. Yeah. Very nice, very nice, very nice. And I did reload up them into those buckets, so we should have them in there as well. Bucket there. This one, full demo. There they are. Very good. Very good. We're getting there. We're getting there. Slowly but surely. Slowly but surely. Let's take a quick stretch here. Also, just relaxing our eyes for a second. So, if you want to join me here, just rub the palms of your hand for a second so they get slightly warm. Then put them onto your eyes. Feel the warmth, your palms. Feel the relaxation. Feel the tiredness going away, getting removed from your eyes. Right. And back we are. Right. So these worked, and we have all the right names. Next one, we get these attribute names. We could just hard code, I think, because it's going to be this. But we can do it anyway. Access denied. I'm calling get object. No. That's not great. That's not great. 3 object dot get. Oh no. We did provide the Jupyter with a role, didn't we? ARM permissions. Root access enabled. I am role, what he says. SageMaker catalog products use role. Make a role created from the SageMaker AWS management console. This role has the permissions required to use the SageMaker portfolio of products from AWS service catalog. Do we have to attach anything to this one? Permissions. SageMaker. Is that the... Yeah, I think it's using this role. Is this one custom created? Let's... Trusted entities. Blah 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 blah. Looks. Where did it go? Service catalog products use. Or can I change the role inside of here? That would be that would be nice as well. We have to actually stop the notebook for that to work. Oh, that was probably a bad idea. It's most likely a bad idea. Because now the data from memory is gone. Most likely. I think worst case that we do is we just add stuff to this role and then at the end of our session we just remove it. So, to be stopped at any time. This is customer managed after all. So I guess we can just attach a policy. SageMaker execute. No, wait. We need the read. Only. Yeah, here you go. I will remove this later on. So. Suppose. Wait. Oh, there it is. Alright, we now have S3 access. So inside of our notebook. Oh, there we go. Alright, so I can remove this again. Move, yes. Okay, fine. Perfect. And we just give the execution role from AWS Amazon SageMaker to the which has SageMaker full access. I was pretty sure this one also has like S3 access. Limited read write. S3. Yeah, that looks good. Okay, perfect. That's what I want. Perfect. So to change the permissions, I had to actually stop the instance and then update it, and now I can restart it. I think. Updating. I'm sure we're close. I'm fairly sure we are close. Just a tiny bit more. As soon as this has updated, we just click run on the stuff that we already did click run on to make sure. Yeah, or we can just go down, and then just run it and see whether the memory has actually been persisted or whether it was completely refreshed. It has been updated. We can start it in new. So that should take a couple of seconds. We do not get any updates here apparently. So I just have to click this do button, up, refresh button. You can do it. AWS, be slightly quicker. Pending again. Pending. Come on, you can do it, EC2. I suppose this is running on some EC2 instance, because this looks a lot like an EC2 thingy. ML probably designed for machine learning. T2 is I think the most regular version that you can get as an EC2 instance. Come on, you can do it. Pending. You can do it. Do we actually see this inside of EC2 as well? Would be interesting to know. EC2. EC2 being the virtual machine servers, essentially. No, we don't see anything. Okay. Security groups, blah blah blah. But nothing about notebook instances. Maybe that's what the ML is for, because that is, maybe that's like a kind of a namespace or something. Come on, you can do it. Well, we can do some more stretching. So try to sit as straight on your stool as possible, and then lift your arms and tilt to the left and slightly shift your body so that your face starts looking. You should feel the stretching sensation. Right. Hip, well, not hip. The upper body. And now back and in the other direction. And slightly tilting. Yeah, that feels good. Come on, Jupiter. Good. Still pending? Come on. Can't be that hard, can it? Ba-dum dum ba-dum bum bum. Oh yeah, Baloo. Is this actually still the thing? I mean, it's probably outdated, right? So, we can maybe look at what's going to happen next. Course. So, in here, we are now creating the parameters that we want to train our algorithm with. So we have like training image. Where does that one come from? Apparently it's object detection. Okay. Yeah, very nice. We use the input mode pipe. Exactly sure what that means. Role ARN is role, which is find somewhere. Whoopsie. Somewhere up there. So we have to rerun this most likely to get the execution role. Where do we put the output data? Into the S3 output path. Come on. Which is defined there. So basically there's GroundTruth OD augmented manifest output directory. And then inside of there we put the bucket name. Then on what kind of resource do we want to actually run this? Apparently machine learning P3 2 times large, which is barely immense. Volume size in gigabytes. So how much disk space it should have in gigabytes, so 50. Training job name is up there, so job name, prefix, and the time span. Then all the hyperparameters. These are for the algorithm. There are several things that you can optimize, essentially. How many things do you want? So it's basically doing probably essentially gradient descent. And there you at least have like step size and how many batches you want to do at the same time and whatnot. How many iterations and all of this fun stuff. Apparently it also has like a base network. Use pre-trained model. Number of classes. And whatnot. Stopping conditions. The maximum is seconds to hours. 24 hours. Okay, that's long. If we do this on stream, this will be a fun stream, I think. Meaning it's going to be terribly boring. Number of training samples is, I think, we can either hard code this or we make object get work. I hope we can, I think we have to get this one working. Otherwise we run into trouble with the output stuff, because this won't work. What else do we have? Input data configuration. Channel name train. So just some name for whatever input data we have. Where this actually comes from, and that's the path here to the train.manifest. Apparently this is called an augmented manifest file. Okay, good to know. And then all the JSON attribute files, which in our case is just like 2 of them. Content type, apparently this is an X3 cord IO. Okay, good to know. Not compressed. And then we have another one for validation. All right, very nice. Hopefully these are in the right format. I do think they are. And then we just format everything, and finally here we create all of the fun stuff. Okay, so as soon as this has actually started, we can open it once more. We should now see the notebook, hopefully. There it is, very good. And we can, this one, 11 hours ago, how can that even be? Okay. All right, we got this. So let's rerun. Connection failed. No. Am I still online? It seems to be. Okay. Come on, you can do this. You can do this. Is it working now? Let's run this. I think it worked. No. Forbidden. No! No! Why? Okay. This one should have access list read write limited S3. Seems to be alright. Let's look at it. It is T-time test 2022-09, which is exactly this one. So that seems to be alright. Why did it not work? Why did I even run this one? I should run this one first. So that worked. Running this one now. Okay, now it worked. All right. Probably because it did not, I had the focus probably wrong. And thus it had basically no this variable here most likely was empty string or whatever Python does, or null, something. Let's go to train and something. Okay, let's do this once again. Inside of here, we run this code. That's good. We had this earlier. This is just a warning, I think. Just run this one. It doesn't work anymore. Bye. Client error. Never quite X denied when calling the get object operation. Still? I mean, what is this variable? Print U. Do it once more. Wait, it worked this time? but it didn't print anything. Oh no, it did. Did it work this time? Okay, I can accept that, I guess. So attribute names we just override here. I don't think we need to do this anymore. So, like so. And now we run all of this fun stuff, which worked. And we see the output here. So input data location inside of this S3 bucket. And now comes the moment where we can actually finally create the training job. Do it. Training job in progress. I think we did it. We go to SageMaker. Where do we actually see this? Training, maybe there. Training jobs. Probably that one. Look at it! We did it! Oh my goodness. Alright. So under training, it's something like algorithms. We could create this also manually. Let's maybe get it at least. Algorithm name, description, training image, and channel stuff, which is pretty much the stuff that we also have here, right? Parameters, algorithm specification, roles, the channel configuration, and so on and so on. Right, very nice. Kill this dude, that one. We're getting there, we're getting there. I think we now have something running. Isn't that exciting? We have our first machine learning algorithm running. So it is still in progress. I have no idea how long this will take. I mean, we did set like 24 hours of time at most. That's a lot. That's a lot for one stream. So maybe we just run this to see whether it's still running. It is still in progress. Secondary status, it is downloading. What is the secondary status? AWS SageMaker training secondary status, was it? Secondary status. So apparently this is an optional stage for algorithms that support file training input mode. It indicates that data is being downloaded to the machine learning storage volumes. So probably it is downloading images from S3. And then at some point it should go into the training phase. And then once training is completed, it will upload the model artifacts, so the actual trained model, into S3 again. So hopefully all of that works. And it has actually the right conditions. And then we should hopefully see the completed part. Okay, very nice. Did it change? It is not raining. Okay, very cool. Very cool. It would be nice if we at least could see something, but well, not much we can do, I think. View history. Ah yeah, okay. Downloading the training image. Sweet. Sweet, 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 sweet. Let's hope it's awesome. Let's hope it's awesome. Input. does not have an output path. That is kind of worrisome. No, here it is. Okay, perfect. Very good. Train progress. Yeah, there are a lot of words I have no idea about. And probably people who are more into machine learning would know what like base networks are, what epochs are. Oh, what just happened? What just happened? Like seriously, what just happened? Hey, training image download completed. Training is now in progress. So I think it showed us another history step. So now it's actually training. Very cool. So sweet. It now has like 24 hours time. But I don't think it will take like 24 hours for just 40 images. That would be very, very long for 40 images. Just imagine doing it for like 1000 images then. That would be a lot, right? So what do we expect from coming out of this? First of all, we know how to actually do stuff. Apparently it's now in progress. I think that wasn't that the same status that we had like a minute ago? I didn't click anything. This popped up automatically. So what do we expect? We want to have a basic machine learning algorithm model that we can then deploy to make predictions with. That's the basic idea. And these are also, I think, the next steps that we have inside of here. Yeah, it's deploying the model. And now that we've fully labeled our dataset and have trained the model, we want to use the model to perform inference, meaning we want to actually use it and predict some new stuff. Object detection only supports encoded .jpeg and .png image formats as inference input for now. The output is in JSON format or in JSON lines format for batch transform. This section involves several steps. Create a model for the training in output, then batch transform stuff. We will just do one, I think, and then host the model for real-time inference. Create an inference endpoint and perform real-time inference. Right. Not sure whether we actually have to host it, but I think we have a basic idea of what we have to do. So at the very, very top we had like let's run this once more. Did I start another one accidentally? Oh, please don't have. Hope I didn't restart it. No, apparently not. Hopefully it's idempotent. That would be good. This one. Run. Right. Still running. Okay. So at the very top level, what we did, we were labeling stuff with GroundTruth, so that we created datasets. We then used this notebook. Essentially, we could have done this with the CLI, but doing copy and pasting all of the configurations into the and adjusting the parameters for the AWS CLI is probably not much fun. And with that, we created a training job, which is now creating our actual machine learning model. And then we can use that model to actually do stuff. So apparently training takes about 15 minutes on this like 1000 object data set. Excuse me. So we should be there in some time. In hopefully no time, but in some time. Training is in progress. Yeah. Very, very nice. Then we can we then use inference? Probably we go to model. We just create a model. Provide model artifact and inference image location. So this is the way I think that we could create a model manually. And just point it to the S3 bucket that we now create, essentially, with this training step. So the output will be something that is lying inside of some S3 bucket again. And then we probably can just post this right there. Not sure where this one is, however. Location of inference code image. Right. Cancel. Probably we will see at some point something right there. What is our friend doing? Can close that one. Notebook changed. Notebook file has changed on disk since the last time we opened or saved. I don't need this anymore, so just cancel. Just close it. Leave. Good. Let me go down to the bottom of the C. And in here, we can just rerun this once more. It is completed. Very nice. Patch. Now we can just put this into the training info variable and go down. From here, so we have this training image. Where does this training image come from? Ah, it's this one. So SageMaker, Amazon estimator get image URI for this region. Use it for object detection, or use object detection, and which kind of repo. Probably this is giving us a pre-built code image that our model is then running against. But I'm guessing here. Be aware of that. Are we back? Deploy the model. Yeah, there we go. So, we have model name when we just print it. Then we take the model data, which is training info, which is defined where? Right there. Ah, that's the name that we created just now. So it should be something like client described training job. Ah, and we just get the status right there, but there is more to it. We do something like this. Do we see anything? The training info, and we do not take it at this position. Just do that and run this once more. There we see all the fun stuff. Good. That's a lot. That's a lot. Okay, and there we take model artifacts and S3 model artifacts, which is probably the output somewhere inside of here. Take this and put it right here. Model artifacts, S3 model artifacts. is this string here. So it's a tg tar zip file where everything is inside, and we see our S3 button bucket right there. Okay, what else do we do? We prepare an object that has that will be used then for the actual creation, and we provide the training image. Is this pre-built code and our model data, which is the location, this TGZ file. And the next one is we create the model with this role, primary container being this dude, and model name, this one. All right, do it. It worked, I think. No, it didn't. Oh no. Name SageMaker client is not defined. Why? Oh no. This one. Go down to the bottom of the C again. And then we use U. Time. And this one again. That worked. Will you look at that? Starting to get a hang of it. And I suppose we now see something inside of here. Look at that. So inside of inference, so SageMaker console, down, inference, we see the model right there. It has exactly the stuff that we have provided to it. The name in particular, when it was created, and so on, and what training job it's referring to. Very cool. Very nice, very nice. So it just works in this case. Well, it didn't quite just work, but we fixed it. And now they want to create a batch transform job using the model created above to perform batch predictions. Okay, so this is going to be it. So now comes the prediction phase. We want to use our machine learning model that we now have, right here, and do predictions with it. We have something like endpoints? No. So, where is our, there it is. Batch transform. Thing is, what do we do with this here? Test annotations B box CSV image.file name. Where does this image come from? Split. Oh, this is an object, huh? Is this an object in Python? Or a dictionary? Then we open some kind of file and we write into it, I guess, huh? Line.strip. No, we read all the lines. Where does it even come from? Operating system wget. Open images. Dataset test. So it's downloading some kind of image apparently. Not sure where this test bird comes from. This here, huh? Then it's copying the images into S3 again. Then creating a job for whom? For SageMaker. Create transform job. What does a transform job do? SageMaker transform job. That's a transform job. A transform job uses a trained model to get inference on a dataset and save these results to an Amazon S3 location that you specify. Okay. I just want one, to be honest. I don't even want to perform batch transformations. You create a transform job and use the data that you have readily available. Transform input, transform output, transform resources. It provides the ML compute instances of the transform job. Oh. Okay. So this is apparent. I think this is the inference, huh? Transform job uses a trained model to get inferences on the dataset and save these results to an S3 location. Okay. Sounds like the thing that we want to do. We don't want to do them on these images. We want to use our own images. Real-time inference. So this section involves several steps. For inference on some, like a hosted endpoint that we can just use with a UI. That would be nice. Similar. I mean, we did something similar with Canvas, right? Was it? When we opened that one, what happened was that we get into this nice UI, and we just selected a data set, port 1, put image, for example, and select an image. It's not an object. SageMaker Canvas pack. Image. Not sure. It doesn't seem to be designed for these kind of for JPEGs. So that's a bummer. We use Studio. Does that look like? Maybe we have more luck with this one. So it's also using a Jupyter server, but probably not what we want. I guess we can just stay with this one. Meaning we need to do. I think we create the endpoint like they do right here. That worked. Sorry, the endpoint configuration, and now the endpoint itself creating. And then have to upload images, and we somehow have to get those images somewhere. In this case, here. Just if we go to S3 one, go to, I can probably just create 1 or 2 images. Yeah. The first 5 images, take these and I make them public. Move. We create a folder, call this public. Date. Copy 5 images for test. Copy into I need to go back more. Just have this file path. Once more, take all of these images. But by now we can move them, right? Don't take S3 colon double backslash this one slash GroundTruth input slash public. So take that line there. Now we can just browse S3. Okay. Okay, I could have just clicked here. I noticed now. Alright, at least the path is correct. So move all of those there. That's done. Then yeah. It said success like a minute ago, didn't it? Ooh. Okay, there. Use destination. Move. Successfully moved. Go to the specified. Hey, good morning, homeless. We have a different color every day. Oh, good evening. I'm doing okay-ish. I'm getting kind of tired after fiddling around with this Jupyter thingy for way too long, and now I opened the SageMaker Studio and it's just totally overwhelming. But I'm now at the point, finally, where I did deploy somewhere. This one? That's where I did deploy the model. So I did train a model finally on like 40 or 41 images, and I created a a deployment from that model. So now what I try to do is create public images, so I can just put them right here, and then put those images into the thing, and hopefully we actually see a bounding box inferred by our algorithm, which is probably a terrible, which probably just will look terrible, because we have like 42 images are not much, right? And even they have different starts, like somewhere in English, somewhere in German, and so on. So probably it will not be great, but if we see something, then I'm happy. Then I'm already kind of happy. It kind of shows me the basic idea of going from labeling stuff yourself to training a model to go to finally inferring, predicting new results. So kind of excited, kind of tired after doing all of this. How are you today? Hope is all right. So I moved all of these into public now. What I want to do is just make these public. Wasn't there like a button here with pre-signed, download as, edit metadata, rename, open, PS3 URL, object, download as, query. Doing good. Started learning SQL. Ah, very nice. First I worked a lot with Mongo and Redis. Ah, sweet, sweet, sweet. So you're the Mongo expert. SQL is not... The basics of SQL are not that hard. In particular, if you worked with MongoDB, a lot will feel very, very similar. When it goes into the details, of course, there's the devil. The devil's always in the details, right? Let's make this one. Okay, it's bucket owner and forced setting. Object. Stores data in tables, documents. Yeah. I did write. Did I? No, never mind. I thought I once wrote a blog article about that, but I didn't. Never mind. It was about MongoDB and then Mongoose language for MongoDB users. They won't help you. But I think there are like SQL terminology for MongoDB users. Equal to MongoDB mapping chart. Even from MongoDB. Yeah, so maybe this helps you. If you haven't found this, primary key, table joins, just look up index, column, row, table, all this fun stuff. I think I never went into this deep stuff. If you are interested, shout out to, I don't know the name exactly. Is Matty Two Shoes? Who's like the secret pro. He's like the secret pro, if I remember correctly. Yeah. If you haven't heard about him, check him out. Yeah, that's right. And he's often doing. I think it was. He's often doing SQL stuff, being data dude. If you're in Finite Singularities chat from time to time, shout out to Finite, he's amazing. I'm there in his chat like probably at least once a week. Django reading IMAP for data? Yes. In particular, so he's doing a lot of Python, but he's working on his day job, which is pretty amazing. So you can see production level code and not just fiddly diddly stuff like I'm doing. So bucket owner enforced is applied. Right. How do I set those again? Probably on the bucket. Not empty. Point management permissions. Lock all. Looking at the objects are not object ownership. I think that's it. Control ownerships of objects written into this bucket from other AWS account and the use of X control lists. I think that's what we want. ACLs, so access control lists, should be enabled. And I acknowledge. Good. And now we can go hopefully into the bucket and make the objects public so we can actually download them. That's the wrong one. Yep, public. And then all of these dudes. Metadata property. No. Do I have to do this one by one? Edit. I want to have public. I cannot set you public. Public access. Still. Okay. Probably creating a new one. I just want any kind of file storage. That's all I want. Did you start learning for your day job or out of interest? No. What do you use for your personal product? Oh, very nice. Yeah. SQL can be tiresome. I gotta be honest. Having used both Mongo and at least as long as you have a schema in Mongo, that's pretty nice. The hard part with tables is all of the, if you have your domain model and you have multiple tables and you need data to be linked together, that's where it's getting ugly. Particular, that's where it's getting ugly. Joins, yeah, exactly. Come on. Now, allow me to set these freaking permissions. Oh, finally. Read object. The object. Yeah. Good. All right. We have public access now. There it is. Isn't it beautiful? I don't want to actually have Nestle inside of there, but well, can't be helped right now. IT is changing fast and there's a lot to absolutely. Hey Max, how are you doing? Did you also change your color? Or is it Twitch just randomly assigning colors to people? So inference, we created the thing. I also created the endpoint now. And now I have to go to the test image, which is somewhere up, right there. I hope I'm not doxing too much. But it's public anyway, so should be fine, I hope. Is it this? So, all right. So what I want to do now is, hopefully I will just see this image if I'm not mistaken. Do it. Command not found. But great. The bytes like object is required, not string. Fortunately, you don't have to learn everything, because as long as you're working in a team, you can help each other out. Sorry, which is very, very importante. This one is not working. IPython.display. Did I ever import IPython anywhere? Ooh, I hope I don't dox too much. Let me move this to the other screen. Type error. Bytes like type. Hey, Vio, the queen of has she. Really? Yeah, 40 minutes ago. Oh. That's quite some news. That's quite some. It was a symbol. Quite a symbol. Immense degree of popularity. Also, welcome to the stream. I hope that's okay to still say. Trying to figure this out. A bytes like object is not string. Image. I'm not sure. How can I actually change the stuff? I do this. Okay, that's nice. All right. So test bird is not defined, most likely. What actually is test bird? So all I want, I think, is wait. What do I actually want? Check the results. No real-time inference. Create the endpoint. We did all of that here. I want to create the image, open test image, read byte as variable name f, read all of this fun stuff. So we have the image inside of, I think, payload then. And then we invoke the endpoint with this payload, which is marked with content type X image. Then we draw it. So, can I provide, any of you Python pros out there, can I provide a URL to open? Python 3 open URL from URL? No. I cannot. Python 3 download image. So here it's downloading the image using wget, which is installed on the Jupyter. I think we can just, shouldn't we be able to do something similar? If it's just wget that we need to use, should be possible for, right? How do I create another one? Yeah, there we go. So, we call this image, I don't know, test JPEG. And then where's my S3 bucket? There it is. That's not the right one. Oh. Yeah, there it is. Okay, close that one. We can also close that one. Where's my Jupyter? There we go. So we just put you right there. That should download it. Not sure where it actually downloads it, but probably in the same directory that Python is running from, huh? I suppose. Let's do it. It didn't work. Resolving, blah blah blah. Connecting. Let me do this to not dox the machine. HTTP request sent. Yeah, okay, no. We can look at the output together, I think. Resolving, request, response awaited, it's downloading it, saved it. But then, bytes like object is required, not string. Okay. So, how do we use IPython display image? Image. Maybe we just call example. File name equals, okay, probably that's what's missing. File name, oops, there's an F missing, equals test image. Maybe that one works. We don't need to do this again, but I guess it's gonna do it anyway. It saved it and then it's not working. Where does it actually save it to? Oh, because it has this name instead. Again. Hey, there we go. Would you look at that? This is my decaf coffee, by the way. All right, very good, very good. And now we're going to call the inference, and then all of this probably not defined. So this should be fine. This should also be fine. It's just reading it in as a byte array. It's then calling the AWS SDK for SageMaker runtime apparently. Then invoking this endpoint that we have deployed, which is visible somewhere. Somewhere here, I think. There it is. Okay. And from there we call it with the image. So we send this image up here to the deployed machine learning model, and it will then do the inference thing, and we read the response, load the result as a JSON, get the predictions. If the prediction, I just want to first of all print result. That's probably a good idea. Return URI equals batch URI is not going to be defined. Whoops, batch URI is not going to be defined. Make predicted image. Oh no. Oh no. It's doing the thing of actually drawing it, I think. Oh no. We have this, we have that. Do not have a U. Batch output. Darn cross-reference. I just want to use it for one single image. How hard can it be? This is already taking me like 2 hours. Oh, come on. So what are we actually using this for? Real-time URI, real-time image. It's using the make predicted image function to actually draw it, huh? Yes, it's using the, in particular, so Boto3 is the AWS SDK in Python. Don't ask me why it's called Boto3. Maybe we can ask the world, why is it called Boto3? Boto was named after the freshwater dolphin native to the Amazon River. Oh boy. Yeah. So talk about bad naming. Boto dolphins. So we learned today about Boto dolphins. Do we actually have an image of a Boto dolphin? Look at them. They're kind of cute. And they're like pinkish. Are these real? And apparently they lived in the Amazon. So what we're doing is using the AWS SDK to make calls to S3, to SageMaker, and anything else. I think that's pretty much it. All of the sub-services of SageMaker, which are a couple. Which are a plenty. So somehow we have to make this work, fortunately. Otherwise this won't really work. mean, we can call it up to this point. But we don't draw it. I mean, we can just, let's call it for now. Would you look at that? That's the prediction. Not much that we can do with. So batch URI is not defined. Yeah, that's exactly the problem that we now have. So we did go up to here. We also got into this part. But down here we failed. And I think this is actually drawing the image so that we can actually see something. So we have to make this work somehow. This one. So Boto3 client, this is calling the S3 stuff. We do not have a batch job name just yet. Let's just create it. Equal to I don't care. Irrelevant. Batch. Let's just call it batch job. We can find it better. Then it's creating the S3 string in this old version of how Python used to do it. It's very, very unreadable. So it's just putting S3 : /, then the bucket name, slash, then the experiment name, the name that we defined up. So these variables are defined way up and are not visible in the scope. That's how these Jupyter notebooks work. I think it is Python 3, yeah. But don't ask me exactly. Somewhere we can use this kernel here, and it's apparently, I think I chose Conda, which is, I think, a version of the Python runtime, if I remember. PyTorch P30, maybe 3.8. I don't know. Python 3.8. So this should work good. And then list them. Make predicted image. Hopefully it cannot have any cross-reference to there. That's good. Batch input, batch output. There it is. Where's batch input defined? Oh. Why do you not copy batch input? How did you learn Python? I used to work as a Python developer, Django. So I can read it. Actually, you probably can read it as well. There are a couple of weird things, like this one. You could rewrite this, for example. You are used to JavaScript, if I remember correctly. So this kind of string you could today write, I think, like this, which is more readable. In JavaScript, you would write something like it's 3 : / I think $, bucket, and so on. That's the without that one. That would be the JavaScript thingy, like template literates. And this is the kind of the old way. It's putting this bucket inside of there and there. I find this one to be way, way, way more readable. But sometimes you still see this version. Maybe there's also a different at runtime or otherwise. I don't know. Sometimes you hear the word F strings because it's using this F. And I think that's a Python 3. something thing. Yeah, I think so too. Absolutely. This is just way better than... Here you have to actually do the parsing yourself to put the right thing in the right position, right? Anyway. Other than that, I like Python for its readability most of the time. A couple of things you have to learn, like array generators and array list comprehension is what they call it. So, but other than that, it's very readable. In fact, I sometimes write Python as pseudocode essentially. So while true colon and then if status is complete, dot, 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 dot. So I think this is very, very readable, even for somebody who cannot really code. Something that you have to be more comfortable with, however, is these kind of name parameters. So Python is, I like it. If it would be typed, I would like it more. But I recently tried it again once more with Django 3 and Pylance, which is a project from Microsoft, and they actually work together with the TypeScript team on a weekly basis. Python by now has types inbuilt, but it's way underused, to say it like that. At least as far as I have seen. But this is pretty good if you want some static type checking and auto completion and all that fun stuff. But this Jupyter notebook, for example, is not typed, so there's not much I can do. You can go fairly comprehensive with Python types, but many people don't do it. So let's see, where was I now? We wanted to define this here, and for that I think we had to define batch. Where is it? Does it support generics? I don't know. I don't know. You love Python X, so you have some experience with that. So maybe you can answer the question whether it does support generics. You can define, so Python is duck typed typically. So if you have the right interface, kind of, you can, I think that's the way that you do generics. Just essentially define the interface and then do stuff. I don't know. I can't remember. I didn't get deep into it enough, I think, to answer that question. But maybe somebody else can help from chat. So inputs. Outputs. Not good. Because so this variable is defined somewhere where I have no idea. There it is. Okay, very good. This we have. Man, I think we have like 20 different names for exactly this. Pretty much. So let's go down and just paste it right there. That's where we define it. And batch output. For whatever reason, the copy paste does not work inside of here. This time it worked. Okay, I don't know. Weird. I defined it down there. Okay, very good. Yeah. No idea why I defined it in different places, but whatever. If it works, it works. So we have those two variables. We have the bucket. We have the S3 client somewhere. There it is. Anything else that we need? Batch boxes data. It's defined right there. When I finish learning SQL, then I will learn Python. Oh, sweet. Yeah, Python is I think a language that is worth at least looking at and getting some inspiration of what's possible. I still think like list comprehensions are a great thing. I think it is very, very, you can write if you try to. Here we see a list comprehension, by the way. You have like an array, they call it list. And then you iterate over so this is basically a map in JavaScript. You iterate over all the predictions, but you also filter right here with this if condition inside of the inside of this map. So and sometimes you can it gets very, very natural language like. So if we read this prediction for prediction, not sure why they call it twice. So usually you have something like a prediction in predictions if prediction at position 1 is greater than 0.2, which means you take all the predictions out of the predictions array that fulfill this this variable here. Yeah, in this case the if is the filter, but you can also map doing this. I think this is here it's doing the mapping. In this case it's taking the identity map, saying in other words it's doing nothing, but we could say something like prediction at position 1, for example, to immediately also have a map inside of there. I think that's very, very elegant. Arrogant. Elegant. And close to natural language compared to array.filter.map. What we use in TypeScript and JavaScript. So let's run this. I think we might be able to do it. As long as I run import numpy somewhere. Is this like a global? Come on, where do you import this? There it is. Okay. I think we ran this. I think we ran this first one, so we are good, I think. That note. Let's go back down to the bottom of the sea, where you can make SpongeBob and this. How do you declare variables? You just write variable name is equal to something. That's it. Def is declaring a function exactly, but for example here you just create the variable if you would just as you would in like in JavaScript. Right? You can just write x is equal to 5 and it creates the memory kind of for x, the variable x. So very, very simple. Yeah, this one I want to run now, but it works. Key error contents. Excuse me. I need more tea, I think. Yeah, so Python is very, very readable and actually a great way to start programming. I think even a better way than JavaScript because it does not have as many what the fucks as JavaScript. Here. Here are contents. Oh, I should probably read this one first. Key error. I think it will actually be simpler to downgrade from something like TypeScript or JavaScript to Python. Downgrade in the sense of it's not necessarily a worse thing. Absolutely not. It's way better than JavaScript, if you ask me. But that's a personal opinion. And the few things that you have to get used to is a couple of the syntax weirdness, which is just different, right? But that's the thing that you can get used to. Understand named keywords, understand list comprehensions and generators, and well, the built-in stuff, which is just like for example, this string function here is something that you have to just know that you can use. But then again, I find myself in JavaScript, I also just look at the default libraries. I often just look again and again and again and again. How do I actually do a fetch call with a method, a post? Just Google it and then. All right. I was getting excited. The people using new stuff. I feel you. I'm trying to watch, to not watch too much new stuff, because I would probably just do everything. What is happening here? So line 55, we do not have line numbers. Great. Where is this line here? There it is. Something is not working. List objects. But isn't that a good thing, in a sense? I mean, you're getting excited means you want to learn and getting motivated. Way better than having to actually be on the opposite side and be like, I don't want to learn. And now I have to stay in the job market or something. So then again, right? The grass is always greener, so I feel you as well, because I'm more on the getting excited side as well. Why is this one not working? I don't know, I have something in my throat now. Because list object is a function that we define. There it is. And it cannot find the response. Where is actually this response object? Oh, it's there. Very nice. UI design, sweet. So you probably have some experience with what's it called? I used Framer, but the popular one, Adobe InDesign is another one. One of those. Figma. Yeah, absolutely, that one. I think that's a great thing to learn. If you ever have the desire to build any kind of UI, just being able to use one of those UI design tools is going to help you so much, because you can actually do it together with your client, right? and then just plan instead of actually having to build everything. And you cannot be faster. If you have some experience with Figma, you cannot be faster than and actually build it instead of just doing the design inside of Figma. Yeah, designing, prototyping. The one that I'm trying to use is called framer.com, and I used that for the C# project I did the other day. This one is very much designed for rapid prototyping and not that much for design, I think. It's much more on the prototype side, being interactive. What do we actually want to do with this? They take content.keys for content in response contents. Oh man. Do they just create one single object? We can't do that. I think we can do that. Let's go down, down, down again. There it is. Yeah, I want you. I think I want you. I think I want you. In here, we put this image once more. Run this. There it is again. And now we can copy it. Done. And now, oh no, it's still uploading. Which that should finish in a very quick time, I think. And now, where do they use these image ID? Apparently nowhere. Okay, very good. We can just create this job. Do it. Transform job name, blah blah. Did the upload complete? I hope it did. We now create this. Yeah, create this transform job. So inside of SageMaker, I think it wasn't in training, experience, processing. I don't know where. Somewhere. Those anymore. We create this transform job. Not sure where it's actually going to show up. This, by the way, is the rest parameters. Sorry, the spread parameter. So that's the same as doing ... in JavaScript. This double star, I think, if I remember correctly. I've actually never used that because I was working in Python 2.7 and not in Python 3. Then we just wait until it completes. Let's do this. Resource limit exceeded. No. Count service limit is 0 instances. Current utilization. Oh, darn. Come on. We cannot contact we can contact AWS support now. Let's just downgrade to a version. It's just one single image. Where's here? I don't want extra large. I want to have medium, maybe. I'm just guessing. I hope that's a thing. And now we do this once again. An error. Okay. Validation exception. Member must satisfy enum value. Extra large, extra large, extra large, extra large. Seriously? Seriously? Which one can I use? This one probably. Machine Learning M5 large. It seems to be the smallest one there is. I suppose ML is for machine learning. So, do that again. This time create the batch job. Create it. I have no idea where this actually is, but it's supposedly inside of SageMaker, so should find this somewhere here. Maybe in processing? No. Maybe in compilation jobs? No. Maybe in not notebooks? Not. Oh, probably not training. Oh, that's the one that completed. 11 minutes? Oh no, it took 11 minutes. Endpoints, batch transform jobs. There it is. Okay, very good. In progress. So that shouldn't be too much, right? I hope that's only one image that it's actually working on. I sure hope it's only one image. Can we open this? Yeah, it's only one image. There we go. So that should actually finish very, very quickly. And then we can hopefully continue on our quest. But it's still in progress. Probably because the instance has to actually spin up, do all the stuff, upload it or download it from S3, upload it to S3. So I suppose there's something to do. And is it actually doing the predictions? I think it's doing the predictions as well, right? Yeah, get predictions. Come on, you can do it. In progress. That's 2 minutes. Come on. Come on. You're running on one of the large instances. It can't be that long. So let's take a quick stretch right there. Put your hands up in the air. Make a straight back. Maybe sit on the edge of your chair if you're sitting on the chair or if you're on the couch. So that your how are these called? Upper legs are not on the chair anymore. Then you can make your back actually pretty straight. Hands up and just do a quick stretch. A good one, and maybe. The one side so that the shoulder blades also get relaxed ever so slightly. Very next. How far are we? Okay, we can continue. Sports with Mirko. Now grab your wrist, and now we again do the thing. Have a straight back, ideally posterior tilt in the hip, and then shift to the left side without moving your hip, without really moving your hip. So you're so the place where you're actually sitting is still kind of static, and you're just tilting. This part of your should move, and that's exactly also where you should feel the stretch. And also, if you want, you can also do the standing up. Maybe cross your legs, which actually helps doing this, because then you're actually doing it completely to basically the up down to your feet. And now grab the other wrist, and again Put your hands up in the air. And then tilt to the right side this time. So for me it's right side. I think on screen it might be opposite. Yeah, so I don't know. Right side viewed from me. Oh, that's so good. So, are you ready? Come on. Can't be that long. Just one freaking image. And I actually have to pay for this. And maybe now, what else can we do? Maybe no, we did basically that. Every just moving those shoulders and duration 5 minutes. Yeah, the duration just updates every it's just counting upwards. Yeah. That might be confusing. It's not saying it will take 5 minutes, it's saying it took already 5 minutes. No, it's saying that's a bit confusing. Do we actually see anything in terms of the status right here? No. Approximate batch transformation duration 2 minutes. Not quite. For one freaking image? You can do it. Maximum concurrent transform 60. Yeah, we do like one. I pay per minute or even per second, if I'm not mistaken. I don't think. SageMaker batch transform pricing. So basically it's still running on EC2 instance, right? I think, if I'm not mistaken. And depending on the image that you are using in EC2, you're actually paying either hourly or is it minutely or even second? EC2 pricing per minute? Can I have this in English? No, not a thing. Yen. Thank you. Read here on demand. I think there are a couple of instance types that actually price you per minute or something like instance types. Details. You see the pricing anywhere here? No. Okay. How far are we? Completed. Yeah. So now we can go back up to our friend here. We now have the. Wait. Where does this batch job name come from again? We are not allowed to override this. Wait, which one did I actually execute just now? I executed this one, right? Okay, yeah. So we're not allowed to override the batch job name anymore, because otherwise it will not match what we have here. Yeah, it's called now object detection model apparently. And then the name. All right. So fortunately, I think I did not execute this. So let's, just for the sake of debugging, print this. So print is your console log. And in old versions of Python, you actually sometimes see this, which I think is actually pretty nicely readable. But as of Python 3, you only see this one. The other one doesn't work anymore, I think. Let's do this. No. boxed image is not defined. Where do we define this? Import. This is way up. But since we skipped some of the steps, but we don't actually want to run all of the stuff, it has not imported this part. Now we just have to find the line again. Will it be down below? Batch something. Yeah, here it is. So let's put you up there. What was the output for batch URL name? Yeah, that was the right one. Very good. So that one works. Now I'm just importing this, and in this case it's not like in JavaScript where you do import and then you either take the default and then destructure and then write like bounding box and so on from this one. So in Python you just invert because the package is the first one apparently. Hey, that worked. Oh my goodness. Okay. The image. GIMP. It is. Oh my goodness. I mean, we did it. We did it. Good job, everybody. High five. It's not quite the output that I was hoping for. Not quite. Just a tiny bit off. A tiny bit. Oh boy. What is this? Oh boy. Okay. I mean, we did it. Right? And now I think we can run this and it should now work, right? That looks pretty much the same. Make predicted image, subplots, blah 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 blah, consolidated bounding box. So what I think is happening, I'm guessing, what I think is happening, it's finding a lot of the things that we wanted to find, and not just one. So it's running the prediction multiple times and finding more than we. No, it's actually probably not even running the prediction multiple times. It just doesn't know that it should only find one thing. So what we could do is probably increase. My best guess here is that prediction at position 1 is in fact a kind of confidence score, maybe. What do? Can I copy you? What is prediction at position 1? Prediction. Come on. Give me that one. Yeah, thank you. So prediction in result at position prediction if the prediction at position 1 is greater than 0.2. So let's try to find out what it's actually referring to. It's apparently picking this array, which is result at position prediction, and then if prediction at position 1 is greater than 0.2, prediction at position 1, it's iterating now over each of these elements, and then it's taking this score here, right? So all of these should be greater, the second array element. Can we format this? Yeah, thank you. That's good. The second array element should always be greater than 0.2, which is, I think, what we see. The bad thing is, if... No, it's not. 0.18, 0.18. Ah. If I print the predictions here, predictions, that should be always greater than 0.2, I think. What was I actually logging? Let's run this again. So do that one again. These are now the predictions. Format the document. 0.2, 0.2, 0.2, 0.2. Yeah, that looks good. 0.20, getting worse and worse, but yeah, it stops at 0.200 something. Now what would be interesting is to find out what this actually is. My best guess is that's the confidence. SageMaker predictions example interpretation. Evaluate the model. So evaluating the model. So we have like prediction in here. Predictions, join predictions, and some other stuff. I think this is different from what I just want. What are we actually calling here? Maybe let's find that out. We call invoke endpoint. Wait. SageMaker runtime invoke endpoint result. This one. So what I want to find out is how do we have to interpret these numbers? I mean, we have a lot of numbers, but what do these actually mean? Looking at this, my best guess is I have no idea what this first parameter is. It's always 0.0, so no idea. Then we have, my guess is this is the confidence score. And then we have like top, bottom, and then size, maybe? Relative. Probably in fractions, or in percent, essentially. Maybe. We would probably need to understand the plot consolidated. Make predicted image. Real-time image, the plot consolidated bounding boxes. AX. Where does AX come from? Ah, there it is. plt.subplots. Do we find the results at any point here. Invoke endpoint. So this is the request. Response syntax. Body, blah, blah, blah. Common data format inference. I think that's what we need to look at. This one? Simple single numeric vector, not what we have. Multiple records, I don't think we have that one. Predictions. Converting data for inference, response deserialization. It returns JSON in several layouts. At a high level, the structure is an array with predictions inside of, an object with predictions inside of that. And this seems to be actually JavaScript now. So, and then, no, this is not our output. This is not our output. Yeah. No, that's also not our output. This one? Shape. Oh, do we have to interpret this? Otherwise, what we have to do is look at the code inside of this notebook and then understand what it is doing. So inside of here, we have make predicted image. It takes the predictions. And what does it actually do with the predictions? Ah, there we go. Do we have batch data in batch boxes data? Where does that one come from? Let me go over to here, which makes it slightly easier to read. Batch data, where do you come from? For batch data in batch boxes data? Batch boxes data is not there. Great. Where does it actually come from? Down there. Get predictions. What does get predictions do? And that's, as you can see, what I'm fiddling around now is basically the stuff that TypeScript does automatically for you, which is document your code. So arguments for the make predicted image is predictions, which is a list output of get predictions. Get predictions, however, does not really find anything. It's downloading stuff. It's taking the... It's downloading some file from S3 apparently. Loading it as JSON and then taking the prediction parameter inside of that. Ah, there we go. Return only the predictions with confidence above the threshold of 0.2. So the first parameter, the second parameter with index 1 of by 1 errors is indeed, where did it go? This one? Yeah. This one is indeed the confidence. So our model is absolutely unsure what it's doing. The highest that we got is 0.26 in this case. Now, what would be nice is to understand what all the other parameters are. Right? What are the other numbers? It's taking batch boxes data. Where did that one come from again? It's super confusing that it's defining it down there, but it's using it in here. Is that even wrong? Shouldn't this be predictions? Yeah, it's not using the input parameter predictions inside of here. Will you look at that? That's a lint I would have noticed, because this should be predictions. Okay. Yeah, that's a tricky part about Python, I think, not having the type safety. And now we see, so each line, so it's class ID 0.0. Now we can understand what this data actually means. It is, so at the beginning, this is the class ID, which is 0.0, and we always only have one label, which is the label called ingredients. And maybe it's actually number 0, but when Python prints a number, it seems to automatically format it as, so there are like floats and so on in Python, I think. Then we have the confidence score, we have the X-min, we have the Y-min, we have the X-max, and we have the Y-max coordinates. Okay, so my first guess was actually correct. And the best guess that we have is like X minimum being at the very, very top, X maximum being pretty much at the bottom, and for Y, pretty much left to right, so it's a complete image in the horizontal direction, almost, starting here at 0.8, so almost 0, to 0.9, so almost 1 in X direction, and then the Y coordinate pretty much the half to the bottom. So what it is actually referring to here, I think, is, let me draw this maybe, this part, almost. And here it is fairly confident that it, with 0.25 or 26 confidence score, which is terrible, that it has found the ingredients. So yeah, but we did it. We kind of found the ingredients in the highest confidence score image. Very interesting that it actually does it multiple times. So it tries to find multiple of these images. Yeah. How do we improve this is now the question. Can we use this? We cannot use it in this form, obviously. This is not useful. What I would need to do is create more labeled data and then train the machine learning model more and more and more and more, and on a lot of data most likely, to be able to identify where the ingredients actually are. Where it's saying lots of data, 1,000 is not lots probably. It would probably improve, probably also by quite an amount compared to 0.26, but 1,000 is not a lot for machine learning, I don't think. It would cost me a lot of money, definitely, but that's a different story. But after that, we would probably get way better confidence scores here in terms of finding the bounding boxes. But we kind of did it. We went from labeling data, so uploading our data, labeling it ourselves using AWS. So let's make a list. So what this one does actually. Don't think we need that one anymore. We don't need that one anymore. We don't need that one anymore. Here. So what did we do? What did we achieve? So we uploaded images to S3 or to file storage, which in terms of AWS is called S3, simple storage service. We then set up AWS SageMaker GroundTruth to label the images, i.e. manually create bounding boxes to train our around the ingredients list, to train our machine learning model on later, or in a later step. Then what did we do next? We well, accidentally we also set up AWS SageMaker notebook to actually do the API calls, and we used the default one and then just adjusted it. After that, or in as part of this notebook, we then created and trained created a SageMaker training job to train our machine learning model. It automatically exported the trained model to S3. Then what else did we do? We created a batch job to do what? To predict bounding boxes on the provided images, and created. Finally, we deployed the machine learning model to an AWS SageMaker endpoint, and no, we did not create a Lambda function to crawl the endpoint. We predicted bounding boxes of an image using the endpoint. That's what we did. It took us quite a while. There was quite a bit of a learning curve and fiddling around with stuff and trying to understand what's actually happening there. And as a result, we have a trained machine learning model that was able to find multiple bounding boxes in the image with very low accuracy, like around 0.2, or max was 0.26 confidence score out of 1.0. We did it! Good job, everybody. Thank you so much for joining in. this is the point where I finally can say stop for today. Like 2 hours more than I actually hoped I would be streaming today. But yeah, thank you everybody for joining in and for the nice talk. Hope you learned something. I definitely learned something about AWS SageMaker. I will now nuke everything. Yeah, nuking stuff. So that I don't have to pay for stuff. Or at least only for the stuff that I actually used. I think we have like one more step inside of here. Down, below. That actually says remove the endpoint. Delete endpoint. We can run that, I think. Then we have... Oh, that didn't work. Oh no, it did. It did work. HTTP status code 200 is a good sign. So that's it. We've covered a lot of ground in this notebook. Let's recap what we've accomplished. First, we started with an unlabeled dataset. Yeah, they round this up similarly to what we have here. So thank you so much for joining. This is the TypeScript Tea Time. I'm your host Mirko. We still work kind of on a startup or validating a startup idea that I have, or building a prototype for that. In our case, learning AWS SageMaker to do some machine learning stuff. And with that, I say thank you so much for joining. Hope to see you next time at TypeScript Tea Time. Goodbye, everybody. See ya.